This is topic 1D, grouped frequency tables. So in our last class, we went over simple frequency tables in which we have one row of data for each value. So in this case, our values are in the first column. Our tally marks are the way to count up the values, count up the number of individuals who elected each particular value, and then we write down the number of those frequencies here. So we see that 5 plus 1, 6 people chose the Honda. So we write 6 as the frequency, and for our work, we also include a percent by taking the frequency divided by the total. 1 divided by 18. And that's what we went over in our last class. We would calculate that out and put that down here. In the second example on the right, we also have a frequency table where the values are numbers. So here are the values, and here are the individuals who chose each value. So in this case, 2 individuals chose 4, 2 chose 5, 4 chose 6, and so on. What I want you to make note of here is that we had to list all the values from the minimum of 4 to the maximum of 10, and that includes this 9. Even though nobody chose the 9. So you do need to include every value between the minimum and maximum in a simple frequency table. With grouped frequency tables, this occurs when we run into a certain problem, and that is the range of possible values is very large. So you might imagine that we are grouping our Facebook friends from our survey that we took, and the number ranges from 0 to nearly 500. If we make a simple frequency table, we would need 500 rows, one for each possible value. That's really too many. It's too long, too much work. It would take up too much space. It would be hard to interpret. And of course, we'd have to calculate out the percents for each of those, which would be very tedious. So instead of doing that, we focus on some groups. In this case, I elected to make groups with about 50 in each, and so I made 0 to 49, so I'll put all the people who have 0 to 49 friends in one, 50 to 99, 100 to 149, and so forth. And this saves us a lot of space because now our values become these intervals. So there are some rules for creating good intervals. First, the intervals have to be equal. Each interval needs exactly the same number of frequencies in it. That is the same number of values, excuse me. So 0 to 49, the values are 0 all the way through 49. There's 50, and it's the same thing here, 50 through 99. We have, once again, the same number of values in each interval. Secondly, we want to create about 5 to 15 intervals. We don't want to have fewer than 5, and we don't want to have more than 15, because either way it's awkward. If we have fewer than 5, it's not really revealing enough information, and if we have more than 15, it's too cumbersome and too dense. Thirdly, we want to use sensible numbers when we can to form the intervals, such as intervals of 2, of 3, 5, or 10 units per interval. And I used 50 up here, a nice round number. And thirdly, we don't want to overlap intervals. If, for example, I find I have intervals that are, say, 0 to 5, and then I say 5 to 10, and 10 to 15, and so forth, we have overlap. The 10 is in both clusters, and we don't know what to do with it. So you have to avoid overlapping intervals. So this would be another mistake a person might make. To make a grouped frequency table, we follow a few steps. The first thing we do is identify the smallest and largest numbers, and we'll call the smallest number the minimum. I'll abbreviate that MIN, and there we go. And we'll call the largest the maximum. Then we want to choose easy numbers for forming intervals. So for example, if the minimum number is 3, maybe we'll begin our first interval at 1, if that makes sense. Or if the maximum number in our set is 47, we might end the last interval at 50 instead of 47, because that's an easier to understand number. Then we want to subtract whatever low end we're choosing from the high end to find the range that we'll include in our interval table. And so if we're including all the numbers 1 through 50, then we would have 50 in our range. We then choose the number of intervals based on factors within the range. And what I mean is, if the range is 50, then we know that 5 goes evenly into 50 or 10 goes evenly into 50, and so we would want to choose intervals of 5 or 10. If the range is 56, we might choose intervals of 7 or 8, because 7 and 8 both go evenly into 56. And then our last steps involve things we'll be doing next class, which is make a histogram and describe the histogram. So this is not what we're covering today. Here's an example that we'll use. A student used a brainwave sensing headband to record the number of minutes her mind wandered during a 75-minute online class session. She recorded these numbers of minutes. And so what we'll do is we're going to follow our process to make a grouped interval table. The first thing I'm going to do is identify the smallest number, which is 3. The next thing I'm going to do is identify the largest number, or maximum, which is 46. So I know that these data range from 3 to 46. I find this a little awkward to work with, so I'm going to choose a minimum value of 1 and a maximum value of 50. Now I know that I can use 5 or 10 intervals. And in our case, for this example, I'm going to choose 5 intervals. So what I will choose is, let's see, I think I'm going to choose an interval of 1 to 10 will be my first interval, and these are our values. I'll choose 11 to 20, 21 to 30, 31 to 40, 41 to 50. And now I can tally the number that goes in each. I'll put this in a separate column right now. And so the 32 will go here. 15 will fit into this category. The 4 goes in our top category. 46 in our bottom. 21, 22, 10, 18, 15, 3, 16, 5, and 20. Whoops, I'll put my tally mark this way, as is appropriate for I'm going to have to cross that off that way. Okay, so now we have our frequencies. And those frequencies are 4, 5, 2, 1, and 1. And the last step in the frequency table is to take each frequency and divide by the total to get a percent. And so the total in this case, 4 plus 5, 9, 10, 11, 12, 13. Is that really what I did? I'm going to count these again. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. That is what I did. A very awkward number to work with. So to calculate percents, we're going to go 4 divided by the total, 13, 5 divided by 13, 2 divided by 13, 1 divided by 13, and 1 divided by 13. So from there, we would take out our calculator, which is difficult for me to get out here in this view, I'm afraid. And so I'm not going to go through and solve these problems that I did with this awkward calculator. And so actually I may be able to get the percents. So instead of putting it on the screen, I'm actually going to locate it on my phone. And 1 divided by 13 equals 0.076923, 0.0769, which equals, in shorter form, about 7.7%. If we, that would be the same right here, 7.7%. 2 divided by 13 is 15.38%. I'll put 15.4%. 5 divided by 13 is 38.46%. And I'll round that also to 38.5. And 4 divided by 13 is 30.76%. And I'll round it to 30.8%. And if everything is done correctly, these add up to approximately 100%, and that's the way you can check your work. So you can see that the grouped intervals are much the same as the individual or simple frequency charts that we made earlier. So now here's 2 questions that we'll answer. First, a teacher asks students to rate their dependability on a scale from 1 to 100. Should we use a grouped frequency table or a simple frequency table? And in this case, the variable is dependability, and the value range is 0 to 100, or 100 is the range. And in this instant, if you said grouped frequency table, you were correct. We should use a grouped because 100 would be too many rows to make. 100 is too many rows. But now I have another question. A teacher asks students to rate their dependability on a scale from 1 to 100, the same as before, but she received only 7 responses. Should a grouped frequency table or a simple frequency table be used? So let's get our key information. We are still looking at dependability. TY, missed a syllable there. And our value range is still 100, but only 7 responses. In this case, if you weren't tricked, you were right. We should still use a grouped table because there are still 100 values. Don't be confused by the scores. We have only 7 scores, but that is irrelevant. It's the values that determine whether you should use a grouped frequency table. So what's wrong with these groupings? Catalina had a lot of responses to the question, how many ounces of sugary soda do you drink per day? Her answers ranged from 0 to 60. She decided to make 3 groups, 0 to 20, 21 to 40, and 41 to 60. The question is, what's wrong? Well, we know that our values are 60 minus 0, which equals 60, so 60 values, and that seems like a lot of rows, so we definitely do need a grouped table. I agree with her. But remember our rule. We have to have 5 to 15 groups, and in this case, she has not enough intervals. So she tried again. After learning she needed at least 5 groups, she changed and made groups from 0 to 10, 11 to 25, 26 to 38, 39 to 42, and 43 to 60. So now we have 5 groups. That seems better. What's wrong with these groupings? If you said they are unequal, you are correct. Notice this one has 10, this one has 15, this one has 12, this one has 3, and here we have, I guess that's 4, and here we have 7. And so we have unequal intervals, which is never okay. So she tried again. And this time she created groups of 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Did she get it right this time? And if you said no, you are correct again, because here we have overlap. Notice the 10 is in both categories. The 20 is in both. The 30, the 40, and the 50 are all in 2 categories. And so she tried it once more, and she got 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, and 51 to 60. Nice, even categories with no overlap, and she has enough to do a good chart. So I have a few more examples that we could do. I'll do one more for this, and then we'll just put a pause on it, and I think that's enough. This is the distance people live from the nearest grocery store, and we have 1, 23, 75, and so forth. So you know our first task is to identify the minimum, which is right here, 1, and the maximum, which maybe is this 103. So when we create our intervals, we'll start with our lowest will be 1, our highest, maybe I will make a cluster at the end and I'll just say greater than 100, because then our last interval could end at 100. So we're going to have quite a few groups, and I am leaning towards, since we're going to have a little more than 100, I think we don't have that many scores. So I think what I'll do is I'm going to make 5 groups of 20. And the lowest group is going to be 1 to 20. So let's put values here and write these out. So I'll write 1 to 20. And next I'll have 21 to 40, 41 to 60, 61 to 80, 81 to 100, and more than 100. So we'll have 6 categories. I have enough 6 categories. I don't have any overlap, and I think the numbers make sense. They all end with a 0. That kind of makes sense. So I think this is okay. Now we'll go ahead and place them. So I'll make a separate column again for tally marks. And I have 1 here, the 23, 75. I'll just keep going through and marking these where they go. $62, 71, 65, 27, I'll cross it off for the 5, a 15, a 10, a 30, another 30, a 45, and a 90. And so if we count these up for our frequencies, we have 4, 7, 2, 4, 1, and 1. We can calculate our percents after we get the total. And the total is 7 and 4 is 11, 13, 17, 18, 19. How I got these awkward numbers, I'm not sure. But we're again going to be calculating by taking F over T. So it's going to be F over T, frequency over total. And in this case, it's 4 divided by 19, 7 divided by 19, 2 divided by 19, 4 divided by 19, 1 divided by 19, and 1 divided by 19. I like to have math usually that I can do in my head when I'm teaching in class, so I'm not sure how I got these awkward examples, but 1 divided by 19 is 5.26%, and I'll just write down 5.3 for the sake of a little bit shorter, and that would be the same for this next one. 4 divided by 19 is 21.1. 2 divided by 19 is going to be, I can just double this, I know it's going to be 10.6. 7 divided by 19 is 36.8. And 4 divided by 19 is 21.1. And if you're wondering, by the way, you've put this into your own computer and you came up with an answer that's 0.211 with more digits, you know that you just multiply by 100 or move this decimal place over 2 points to get 21.1%. And that is the end of the problem. These should add up to approximately 100%, and then we are finished. So what you're going to do is go into practice 1D, which is grouped frequency tables, and see how you do with these items and ask if you have any questions. Thanks for tuning in.